Have you ever wondered what happens when you move your cursor on your iPhone screen? Are you moving matter or information? It's a curious thought, isn't it? In essence, you're interacting with both, but what you primarily perceive is the manipulation of information. Let's break it down. First, there's matter. The physical components of your iPhone, like the screen, are matter. When your finger touches the screen, it alters the screen's electrical state. This material interaction is grounded in the properties of the physical matter involved. Then there's information. When your cursor moves on your screen, that's information in action. You're not physically moving any matter to make the cursor move. Instead, your touch is translated into electronic signals processed by the hardware and interpreted by the software to move the cursor on the screen. So, when you're swiping away on your screen, you're not just interacting with matter, but also manipulating information. Which of them is primary? Historically, the world of physics has often viewed matter as the primary component of the universe. In the grand mechanical clockwork of classical physics, matter was the star of the show. Picture the universe as a vast machine, its gears and cogs whirring in perfect harmony. The information we glean about the state and arrangement of matter, such as the position and momentum of a particle, was viewed as secondary. Like a detailed blueprint of a grand cathedral, it merely describes the structure, but isn't the structure itself. The cathedral, the matter, is what's truly fundamental. In this classical perspective, information is an echo of the physical world, a reverberation of the matter that makes up the universe. It's a representation, not the thing itself. So to the classical physicist, the answer is clear. Without matter, there would be no information. However, modern physics, especially quantum mechanics and theories involving black holes and the holographic principle, suggest that information might be more fundamental than matter. This proposition turns our classical understanding of the universe on its head, presenting a universe not of particles or waves, but of bits of information. In this view, matter is not primary, but emerges as a secondary phenomenon from a deeper layer of information. It's as though the very fabric of the universe is woven from strands of information, and matter is simply the pattern these strands create. This revolutionary idea is powerfully illustrated by the holographic principle, a concept that originates from the study of black holes. According to this principle, all the information contained within a three-dimensional space can be fully represented on a two-dimensional boundary to that space. Think of it like a hologram on a credit card. The hologram is flat, two-dimensional, but when light shines on it, it produces a three-dimensional image. The information for the three-dimensional image is encoded in the two-dimensional hologram. In the same way, our three-dimensional universe might be a holographic projection of information encoded on a two-dimensional boundary. Now, this doesn't mean that our universe is a hologram in the same way your credit card is. It's a metaphor, a way to help us grasp the complex and counterintuitive concept that our three-dimensional world might be a manifestation of underlying two-dimensional information. These theories are still just that, theories. They're at the cutting edge of physics, and there's still much we don't understand. But they offer a tantalizing glimpse of a universe where information isn't just a way to describe matter, but the very foundation from which matter emerges. According to these theories, what we perceive as three-dimensional matter might just be a projection of underlying two-dimensional information. So, is matter or information primary? The answer isn't as straightforward as you might think. This profound question is lodged at the intersection of physics, philosophy, and even metaphysics, influenced by the theoretical framework one adheres to. In the corner of classical physics, matter is seen as the champion. The universe is likened to an immense machine, with matter in the driver's seat, manipulating through physical forces. Information in this perspective is merely a passenger, a description of matter's state and arrangement. However, in the modern physics arena, particularly quantum mechanics and theoretical discourse involving black holes and the holographic principle, information is increasingly viewed as the heavyweight. The universe, at its core, might be composed of bits of information, with matter merely playing a supporting role. Whether you side with classical physics or modern theoretical physics, this debate is a fascinating reflection of our evolving understanding of the universe.